Hi everyone, I welcome you all in my new video tutorial. In this video, we are going to discuss about the most common modeling confusions while modeling structures in Etabs. During my trainings on this software, I have come across so many questions and modeling confusions from my students while modeling a structure. This video will help the upcoming students who are eager to learn this software. Before that, if you are new to my channel, please subscribe to it and press the bell icon so you can be notified on my regular uploads. So in this tutorial, I am going to discuss two most common confusions which are faced by many of us while modeling a structure. So let's go with the first most common modeling confusion. So to shorten the video time, I've already modeled the simple grid lines. So let's place the column first. So we are going to discuss two cases. So for the first case, we will be drawing the beams end to end. So see, the beams are not continuous now. For the second case, we will draw the beam from the first point and we will not rest it on the intermediate supports, and we will support the beam on end points. So this is the most common question asked by many students. Should we draw the beam point to point, or should we draw the beam continuous without resting it on the intermediate point? So since we have modeled the beam, let's analyze it. So I'm not going to apply any additional loads on these two models. So let's analyze the structure simply on its self-weight. So as you can see, the analysis is done, and by looking at the deflected shape, you can figure out it is not going to give you a much difference. So in order to verify it, let's switch to its elevation mode. So we will check the deformed shape under elevation 1 as well as elevation 4. So under elevation 1, if you just analyze the physical pattern of the deflected shape, it looks correct. If you remember, along elevation 1, we have modeled the continuous beam starting from one point A ending at the D point. So now switch to the elevation 4. So for elevation 4, if you remember, a slight lesser deflected shape is observed, and on this elevation we have modeled the beam end to end. For each span we have modeled one beam. Now let's compare the results under moment diagram. So in order to see what is the moment diagram of these two shapes, so almost again they are showing us similar values. So again, in order to compare it properly, go to the elevation modes. So under first elevation, where we have modeled our continuous beam, you will see a results of a continuous beam where you are getting the maximum bending moment at the first intermediate support is -21, and similarly it is -23 for second intermediate support. Now if you compare these results with the separately modeled beam under elevation 1, under elevation 4, so more or less they will also give you the same value. So 18 from the left span, so it is 17.31 from again this side. So on this intermediate support we are getting a bending moment of is -18.07 kPa. But if you model it in a continuous manner, so you are getting a bit higher bending moment. So more or less it gives you the actual picture. Now what's the difference? Though it is giving us the same moment values and same calculations. So now the difference is when you design these beams, so these three beams are to be designed separately, but whereas this whole beam is considered as one and it will be designed accordingly. So let's see what are the results now. So go to the design. So if you see, Etabs has considered these three beams separately and designed them accordingly. But if you compare it with a continuous beam, so we have got a uniform design for all three spans. So this is the difference. Let's see the details of reinforcement. So for beam, as you can see, it is giving us 0.1778 at the mid, and for the left hand side we are getting 0.24 and 24. And for top steel it is 0.45 for the mid span and 0.14 for the end spans. So similarly, now if you can see, for columns we are getting the reinforcement at 0.00, so maybe we have placed some wrong columns. So yes, so instead of columns we have put the details of beams, so we need to revise it if we want. Go to the elevation 4. So for bottom reinforcement we are getting 0.243 as a mid, okay, for first and third span, and 0.1732 for the middle span, and for the top reinforcement it is 0.064 and 0.064. If we compare it with the percentage of steel, so it will give you a clear picture to us. So 0.06, 0.02, 0.07. So let's compare it to our continuous beam. So yes, 0.04 at the bottom, 0.06, 0.06 on this side, 0.01. So it is giving us the same reinforcement. Now what we learned from this, so if you are modeling the beam separately or continuous, it actually does not make any difference to your model. For analysis it is okay to model separately, or if you are modeling it continuous, but when you design it, so each component which you have modeled separately will be designed accordingly. Those components which you have modeled continuous, so they will be designed or considered at one member, and they will be designed accordingly. So our second confusion is, should we draw the slabs individually, or we should go for a one slab for the whole building? So in order to answer this, again we need to go for the analysis results, and let's compare the values. So for the first case we are just modeling one slab for the whole structure, and let's see what are the analysis results. So as we can see, the Etabs have by default meshed all our slabs. So first we will be checking our results with the moment diagram, so that's how we can verify how the load is being distributed in this case. So let's switch to the moment diagram, and if you see, if we take these two beams as an example, so we are getting minus 50.0587 kip fit of the moment at the support, and for this beam we are getting minus 80.0737 kip fit of the moment. Now let's take the shell stresses. So for shell stresses, so we are going for maximum values. So for maximum values we are getting 186, 133 at the mid, 188, and at the supports, so we are getting 343, something like this. Now that's it. Again we will be modeling the same structure with individual slabs. So first remove this. Let's model the slabs individually. Now run the analysis, and again the meshing is done in a similar manner as it was for the previous case. Switch to the 3D view, and again we will be switching to the moment diagram. So for last case we'll be taking this beam as an example. Again we are getting the same values, 50.087 for the first beam. For the second beam it is minus 80.037 kip fit. That means whether you model the slab individually or consider the single slab for whole structure, the loading distribution will remain the same. Now again switch to the shell stress diagram. So for shear stresses, so I don't remember the exact values, but I will remember it was 3 digit and it was starting from 189.88. So all the values was in this manner, and for the supports we figured out the values was 339 and 40. So we are getting the same value. So from the analysis results we can conclude that whether you model it separately or collectively, it does not affect your analysis results. However, it may affect the design results. Because in actual structure the slab may be used for the different purposes. For example, the same slab is used for corridors. Sometimes it is also used for a cover to a room. Sometimes it is also used for classrooms. So for different occupancies we have got the different loads. The different loads give us the different thicknesses of the slabs. So in actual we should have a practice to model the beams and slabs separately so we can design them accordingly. So from today's discussion we can conclude this: whether you model the beam or slab individually or in a continuous manner, it does not affect the analysis results. However, it may give you some different design results. So guys, this brings to the end of today's tutorial. If you find this tutorial useful, please do like and share, and if you have any doubt, please write in the comment section. For more updates, subscribe to my channel and press the bell icon so you can be notified on my next uploads. Thank you and have a nice day.